Hello and welcome to 3 Steps to Selecting the Right AC Drive. This is Part 1, Introduction. Automation Direct offers 4 different models of AC drives. The GS1 mini drive, which is available in 3 configurations. The GS2 micro drive, also available in 3 configurations. The DuraPulse sensorless vector drive, offered in 2 configurations, and the Hitachi SJ300 flux vector drive. There are several benefits of using an AC drive to power an induction motor versus using a cross-the-line or soft-start starting methods. These include adjustable speed and direction control through keypad entry, analog input signals, or communications, which helps eliminate mechanical parts. Controlled starting current, acceleration, and stopping, which reduces starting currents and prolongs the life of the motor in mechanical systems. Realized energy savings and reduced power line disturbances versus using across-the-line starters. Elimination of some mechanical transmission components, since AC drives provide speed and torque control, allowing for simple mechanical transmission designs to be used. And a variety of control methods including 4 to 20 milliamp loops, plus or minus 10 volt signals, encoder following, and commands via serial communication. Deciding to use an AC drive and properly applying one is greatly dependent on the type of system to be controlled. Let's review some of the most important characteristics of a system that should be considered to successfully apply an AC drive. Knowing the type of load is important. Some load types require higher starting torques, while some loads require faster speeds, and some fall in the middle. Most all applications fall within the following 4 load types. Variable torque loads, which require less torque at speeds below rated base speed. Typically, as the speed decreases, the torque decreases with the square of the speed, and the horsepower decreases by the cube of the speed. Some example applications are centrifugal and vacuum pumps, fans and blowers, and agitators. Constant torque loads, which require constant torque at speeds up to rated base speed. No matter how fast the load is being moved, the amount of torque does not change. Some example applications are conveyors, machine tools, cranes, and elevators. Constant horsepower loads, which run above the rated speed of the motor where the amount of torque available decreases with respect to the speed, thereby keeping horsepower fairly constant. Some example applications are winders and machine tools. Impact loads, which are intermittent and the amount of torque is not a function of the speed. The drive system typically drives a flywheel, which in turn delivers the energy to the load. Some example applications are punch presses, crushers, and shears. Correct sizing of the drive is critical to successfully control the system. Many resources are available in books and on the website to assist in determining the size of the system. Generally, this involves determining the system inertia as seen by the motor. This information is needed coupled with the torque and horsepower requirements, speed required for the load, and the torque of the motor. Duty cycle and application type also play an important role in system sizing. When replacing an existing AC drive system, you can generally use the same size drive. How the system operates is important as well. The speed range of the application, how quickly the system needs to respond to the command, and the duty cycle all need to be considered. The type of motor used should be correct for the application. If a drive is being added to an existing application, check that as a minimum the motor is inverter duty rated to avoid doing internal damage that will shorten the life of the motor. Applications that require constant torque at near zero speed should use a vector duty motor. In a new application, consider all available motor options. Enclosure types include drip-proof, totally enclosed, severe duty, and explosion-proof. Many motor manufacturers have a variety of specialized enclosures to fit the application. Cooling methods. Typical motor cooling methods are fans, blowers, water or convection cooled. Fan cooling employs a fan that is attached to the motor's shaft. It is more effective when the speed of the motor is at or near the base speed. Blower-cooled motors allow for constant cooling, which is independent of the motor's speed. Water-cooled incorporates recirculating water to remove the heat from the motor. Convection-cooled means that a fan, blower, or water method is not used. The heat is dissipated through a specially designed case that incorporates fins, which aids in cooling. Brake and encoder options. Brakes can be added to applications that require that the load doesn't move when the power to the motor is removed. Elevator-type applications generally use brakes. If tight speed regulation is required, an encoder is used to provide feedback information. Bearing options. Different bearing types are available from most all motor manufacturers. For general use applications, ball bearings are used, whereas if a pulley system is installed directly on the motor shaft, then roller bearings should be used. In general, understanding as much as possible about the application will help you avoid some common problems when applying an AC drive. Undersizing the drive, not specifying a needed accessory, or using an incorrect motor type are a few of the common mistakes generally made when applying an AC drive. Now that we know some facts, let's start with step 1, selecting the right model.